Yes, and also have screen. So, let's start. Okay. There is no laser pointer, doesn't matter. Yes, let's start with the presentation. Okay. So, at least I have a presentation which was optimized for 16 per 9 screens, but doesn't matter. So yet again, greetings surfings, my name is Gábor Macskó. I'm assistant professor here. That's the highest degree that you can get with PhD and without habilitation. And I'm also a space physicist at the Wigner Research Center in Physics. I have a lot of experience in science and also in teaching. Brief introduction. First of all, you can see my email address. I have a very eccentric, almost pervert behavior. I answer your emails. This is quite rare. Even I cannot send emails to my colleagues. They don't answer. In my research institute, they answer, but usually in university, they don't. So you can just, if you have questions or anything, just send me email. I will send you messages in Neptune. You won't be able to answer, but you can send me an email. Okay, so I'm space physicist, original astronomer, but I'm not very young. I'm 51 years old, 50 actually, for a few days. And I had to learn theoretical physics and to learn astronomy. I also have a computer science and I do computer modeling and a lot of computational related stuff. That's why I can teach in IT subjects, mathematics and also physics. I am assistant professor, I told you what I am. Okay. In 2008, I did my PhD at the Obuda University in Budapest. It was data analysis. Then I moved to France, to Orléans. It's 100 kilometers south from Paris. And I worked there. I analyzed an instrument data and also prepared the spaceborne instrument data. It's not easy, actually. It's not an easy task. Then I moved to Finland. Well, that was great. I learned so-called non-hydrodynamic simulations, and I still do it. Some funny things that I met my former wife in France, and then we moved together to Finland, and both of my daughters were born there. I have a 9 and an 11 years old daughters. My 11 years old daughter is 167 centimeters higher than her mother, and I'm preparing because she will very tall, perhaps taller than me. But I'm not sure, but I have to prepare. I have to prepare a lot of other things because she's already a teenager. In 2016, I returned to Hungary. That was an attempt that was so successful that within 2 years, I moved to Germany, to Darmstadt, and worked for the European Space Agency. In the meantime, I visited the NASA Goddard Space Flight Center in Maryland, Greenbelt. It says nothing for you. It is 20 kilometers further from Washington, D.C., not Washington, that's a state. And it is the middle of an agriculture area. It's the first space center, and there was some guideline to build that. It should have been close, near to Washington, but if a rocket is failing, then it's not good if it kills some administrator or the president or something like this. So they put a bit further in the middle of an agricultural center. It's a funny fact, actually. And from Darmstadt, I returned to this Wigner Research Center for Physics. It is in the mountain. If you go to Chillabert, do you know where is Normafa? Have you been? I asked the foreigners. So you go there. You also you can find the walking distance an astronomical observatory, and then you have to go to the end of the road, then you will find a city. There is a chimney-like stuff. It's a ventilation of our nuclear reactor. It's a military protected area actually, and we do some nuclear stuff. What I do is not that one, but still it's difficult to enter. I was so well paid that I started to work in part-time at the Milton Friedman University. Many colleagues from here also works there. It's a complex university. It's for more. I taught informatics there. C#, Python, Unix. Actually, this is also Unix. What I use right now for some reason. That was great. But my family was in South Hungary and Pécs, so I moved to the University of Pécs. Faculty of Sciences, I taught mathematics, linear algebra, and advanced linear algebra, and a lot of such things. Well, that was nice. I found, for example, a space lab. Yeah, that was great. Still I have students there, but now I'm here. In the meantime, I I had a work contract with the NASA Space Flight Center. It's a secret project. Secret because it should have been in the news, but some reason we thought it's better if just keep to each other. And now I am here and I'm teaching you this one. I have supervised students, one MSc in physics. She's from, in the Hungarian language there is no gender and I don't sleep so much, so I will mix the gender sometimes. So he was from Mongolia. It's Stipendium Hungaricum scholarship. Whom does have a Stipendium Hungaricum scholarship here? You. Okay, stipend. Great. And the others? So? Yeah, so you are a millionaire or something like this, or no? You are a messenger in your half time. No, doesn't matter. And the Hungarians, why do the Hungarians learn this subject in English?
I have plans to study, work abroad one day.
Okay, great. Well, I hope you will enjoy my wonderful Hungarian accent or pronunciation. Okay, you are in your first class, but in your second semester. So, do you know what is a lecture? Do you? Do you know what is a practice? Do you know what is a signature? Why is it important to get? Do you? Don't you? Okay, you know. You know what is the midterm exam and exam? Great. Do you know what is TDK or Scientific Students Conference? You know? Okay. Could you please explain to others?
So like the TDK is a conference where students apply with their research papers, and then when they are chosen, they get to present their thesis or their AC or their research work to a panel of, to an audience. Yeah. Then there are recognition events.
Yes. Thank you very much. And something else. Okay. It's still working. So something else. If you have a thesis, then you don't need to write a thesis here, and do not need. For the BSc and also MSc. And you are very valuable. You are engineers. To be a space scientist is not easy. An astronomer has a telescope, and then okay, that's it. To me, I have to build my instruments, and I need engineers. And the engineers are growing old, so I need new one. Students, everyone. So you are good victims. Subject to have a to have a student, engineer student. Yes. Okay. If you have a BSc, And if you go to an Anglo-Saxon or country like US, Great Britain, Australia, China, Shanghai University, or Turkey, then you can apply for PhD directly from BSc. In Europe, the MSc is the diploma, but in other countries, the BSc is the diploma, and having a PhD is an extra. And some guys does MSc. And MSc is only 1 year or 2 years, 1 year in many countries. Okay, I have BSc and dedicated thesis topics. I have a lot of contact in Facebook and LinkedIn. And yeah. And also, I have a lot of experience writing CV, applications, everything. If you need something and you have a good performance here, then it's fine, I can help you. The idea is that you will be professor somewhere and I will be old and poor and you will invite me for visiting scientist or professor later at that university in the US or South Africa or anywhere. It seems to be funny, actually it's not. You have a lot of opportunities. When I was at the university, I studied at the university, Hungary was not part of the EU. The EU has a lot of fellowship for BSc, MSc students, a lot of collaborations, EUMETSAT, that's the meteorological stuff, European Space Agency, and these organizations has the organizations the core, and there are companies around them, and these companies are something human power exchange or something like this. So it's a lot of possibility for training abroad and these companies. I have a lot of things. I try to distribute this. Only one people listen to me. This guy went then after exchanging a few emails for 2 months to Boston. Then now he's in Oulu and a PhD student. But you don't need to listen to me. So it's just do what you want. Okay, I told you I record everything that I tell you. Also, you will get the slides. You will have the books. You will have the exercise. You will have the test. You will have the test results and everything. I will upload to Moodle, but I haven't seen our subjects Moodle stuff. Perhaps I have to do something for it. I don't know. Last time I started in October, so someone started this stuff. Some guys like Teams, for example, in Page at my former university, they prefer Teams groups. We will see. By the way, I will upload everything to GitHub, so after you leave, everything will be available. If you check my GitHub, you will have this PDF, or just write my name, FCASKO, and GitHub. You will find my stuff, and you will see what I uploaded from the last semester. I also have a YouTube channel for a special reason. Here, that's a good university. This stuff, it's approximately ½ gigabyte per video record. And usually the limit at Moodle, 10 megabytes. So I had to upload everything to YouTube and add the link. It's not necessary here, but I still upload to the YouTube. That paid off this effort. Okay, let's start. Now continue with the course objectives. Yes. Blah 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 blah. Oh no. Yeah. Yes. Okay. Blah 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 blah. Physics is nice. You will enjoy it. Everything. Don't worry. But you will sweat badly. Not because I'm very sadistic. Just here are the first part of the topics, and I will go through and I will explain. Check. Everything that is classical physics is here. Mechanics, thermodynamics, electrodynamics. I need 3 semesters to learn this. There will be some shortcut, but this shortcut It's not helpful at all. I will start the practice with explaining some stuff. Also, I have some confusion. The order. I should start according to this syllabus with thermodynamics. Well, in first class secondary school we start with it. Usually you start with mechanics. Then thermodynamics comes and electrodynamics. Also, I have some help with Siraj Joka and someone else. I have the notes, and there are many poetic stuff in them. I'm pretty sure you are very intelligent and you have the fundamentals. Otherwise, you won't be here. Stipendium Hungaricum has a quite tough selection earnings, but it's too much. So I made some stuff and also had, that was my favorite, in the Hungarian syllabus. I should have tell you the nouns in lecture, and in practice, explain the thermodynamics parallelly. That's the worst thing that I have seen. No, I will not do this. Still, that will be too much. The practice is 45 minutes per week. It's nothing. I will adjust this to you. So, we will have the mechanics. Actually, today the plan is that. Yes, the plan when it started. It's half hour. I have still 1 hour. Great. So we will start with mechanics 1 and 2, but that will be horrible. The next one, rigid bodies. The Hungarian name is quite interesting. Oscillations, wave phenomena, and acoustic. Then thermodynamics comes. Come in. Hello. Welcome. And then electrostatics and electrodynamics. It's too much. It's really too much. And also the requirements. Do worry not, you will understand everything, so that will be okay. Just I will give you homeworks that you should do, otherwise you will not pass the midterm exam. So requirements. Theoretically, I should check whether you are here. Because it's extra administration and I don't have so much time, I won't. But please come. If you don't come, I will feel that my lecture is boring and you don't like physics, and I will be depressed, and who knows what will happen. You will have assignments. The original requirements is 6 assigned homework. Okay, it's too much, doesn't matter. And 4 is obligatory. I will give you 5, and 3 is obligatory. And the extra 2 will give you extra points in the midterm test and the exam. If you pass. If you don't pass, it will not worth anything. But if you pass, then you will have a better grade. Okay? You must achieve at least 40% of the midterm exam for signature. There will be one midterm exam, 18th of May. I proposed the last Monday, the last lecture. And my specialty is that during the midterm exam test, you can use anything except your cell phone and your neighbors, because it's close to the reality. So do not do the test with ChatGPT. It can do this, but please do some efforts. When you do something like linear algebra or computational stuff or physics, not so not that important that you know the formulas. You must have a behavior. Okay, there is this problem. Okay, I know this one. Okay, I have to do, and then I get the result. So just don't just stand there and do nothing. Use your mind. This is the more importance, and this is what I can give you. How to use your brain, your mind, disciplined, and go to direction. During the modern physics, you will have very interesting stuffs. Why the battery is working, why the MR instrument working, why the X-ray examination working, why the microprocessors working. I will explain you. There will be quite interesting stuff also now in this classical physics. But so the most important is to act. If you have any problem, just don't tell. And when you have the exam, that will be a written exam. One step. I'm not masochist. I have to correct everything myself. I don't have PhD students and postdoc and anything that the Western professor. So you won't use anything, but you do not write down everything like a poem or novel. It's not this is not the faculty of law. You understand what I explain you, and you write it in correct way in your own words. That's the physics and mathematics and everything. So it's not like a novel and everything. There will be a lot of at least 4 if you want more occasion for exam. Question right now. Last semester, I have Erasmus students, and they ask me, they ask me to have an appointment, an exam before Christmas, because they passed and then went home. Do you have something similar requirements? Okay, somewhere in April they will send me. They will ask me when the times should be, the exams. We can discuss when it is. So it's flexible. Yes, blah, blah, blah. Okay, the homeworks and the deadlines. There is a nice BS here. Actually, I don't know how we will progress. There will be 3 homeworks. Free homeworks, mechanics, thermodynamics, electrodynamics. And you will have similar exercises in the midterm exam. Once we finish the one topic, I will give you the homework with some delay perhaps. And you will have long deadline. So, okay. Yes, okay. These are the stuff. You must have the signature, that's 40%. You need half of the points and a little bit more to pass. And you can see this. The recommendation, this Feynman book, you can read it. You can use ChatGPT for preparation. You can use internet, but all slides will be available very soon. And also the records and everything. Okay, and the most important discussion for me today. I have an offer you can't refuse. I mean, I have an offer that you can't refuse. I got a job in Strasbourg, so I would like to leave. And I cannot accept the job if I give you this lecture every Monday. So my proposition is that to accelerate this, next Monday and 2 weeks later, I would like to give you free lectures and free practices. That's altogether half of this stuff. What do you think about this?
What do you mean 3 lectures on Monday?
I will book rooms and I will give free lectures and free practices.
On Monday we have a lot
Full
of us,
day.
a full day.
The Mondays for us are from 8 a.m. until 6 p.m. without any breaks.
Okay, and other days
We have, I think, Wednesday for most of us is free.
is free.
Every second Wednesday.
Yeah,
Every second Wednesday.
Oh,
Then I can, if you accelerated the lecturing, then I can give you on Wednesday the lectures. I need your agreement. If you have the agreement, then I can talk to the director of my institute, and then I can start the process moving there. I will return at the end of April, and I will finish the second part of this. In the meantime, of course, we are keep in touch, and I give you the homework, and I will correct the homework and everything. This is a big favor because this is not an easy topic. You have a lot of things in this. What I can tell you is that I wrote there. Last time I had 33 students and only 2 fails. And failed because one didn't prepare the homework, the other didn't just failed in a exam and didn't repeat the exam. That's actually, I'm not soft or mild or anything. Just you will have anything to learn, and you will know what to do. In other courses from the Hungarians, from 18 student, engineering student, 60 failed at the first exam. Yeah. That's the Professor Ratz. He told me, I don't know whether is it correct information or not, but of course they returned and everything. I'm recorded, so I don't want to tell you more. But for example, check my GitHub. What lectures I give. I mean the slides. The first 4 lecture last time was about Hermitian matrices. Yeah. I guess you know what they are, don't you? No, you don't know, because I need 2 semesters in algebra in page to explain to the students what they are. It's important for quantum mechanics, but the rotating black holes are more important, and also there are more exciting topics of this. So do you have any offense with the acceleration stuff? You have a little bit more time. You will get everything, don't worry. You will, I will claim everything, and you will get everything to learn. Just I need to leave for a few weeks.
What about the assignments? How are they going to be?
Sorry?
About the homeworks and assignments, how are they going to be? Are they?
I always upload them to Moodle. And then I will ask someone to scan and send to me, and I will correct, and I give you a table with points and everything.
Are they also going to be accelerated timeline, or?
Okay, the deadlines will not be accelerated, but after next week, I will be able to give you the mechanic homework, because we will finish the mechanics. You will be a bit green, but don't worry, you will be green otherwise, because that's a bit too much stuff. It's okay?
Okay.
I don't mind.
Don't mind. You don't mind. If you mind, you can write me. I consider this a yes. Okay, and this is the timeline, but this will change. I will ask the secretary of the director of the institute to find the days to you. I have to sleep here more because I live in South Hungary. Doesn't matter. It's quite important. You can click to the links. These are working links. What is this university and what is this space studies program? A little bit afraid because I have to give a course like this one. That's okay. It's MSc level. But the other one, 100 people will come. The tuition fee is 20,000 euros, and we have to perform a full course, a full course for 2 months, and then charge to do it. That's great. Actually, I have done something similar without any help. Okay, so now I have time 50 minutes because I talk too much, but that will be enough. So I start with mechanics, classical mechanics. The classical mechanics has three main topics: kinematics, dynamics, and statistics. You will not learn anything about statistics. That's a bit difficult. And also the neoclassical physics like turbulence, chaos, and other. It's a very nice topic, but it's not a BSc topic. You will not learn about it. The problem is that you will not learn about kinematics, but you know everything in kinematics. If not, does not matter. During the practice, I will start with it. So we will start with dynamics. This explains why the bodies are moving. This is not the physics that I would give you myself. I have to follow the syllabus. This is something accelerated stuff. I not really like it, but I have to follow the instructions. Okay, let's start. The simplest mechanical system is when you have a mass point, particle. It has a mass and it has a velocity. You can calculate the energy and you can calculate the momentum. That's P m times T. I will extend this at this. I think that's familiar to you. It's very, very simple. I should start with kinematics, but doesn't matter. Here, something that I should have dropped with a lot of other things. When you are a mechanical system, in secondary school, primary school, you give the coordinates of the points or one point and the velocity. That's enough. That's okay. But it's more advanced if you have a different coordinate system. You have the location and the impulse. M times velocity. This is another coordinate system. It's called phase space. And I really do not know why I explain it to you. Perhaps because this special relation was in this syllabus. Why is it important? Usually you write down a lot of things, the moving of free particles or anything, with coordinates and the impulse. Very nice. Okay, carry on. We don't have kinematics. You mean this straight movements and acceleration and anything. Don't worry, you will have in this practice. So we start with Newton's law of motion. Is it familiar? So the first is very simple. If you have a body, it's normally moving, don't moving, just rest, or has a constant velocity. This is the law of inertia, and there are a lot of things which are related to this. For example, inertia frames and the reference and everything, but everything is just cut and dropped everywhere. Then I jump to the third one. This is the law of action and reaction. If you have a force to a body, then the other body also have the same force to you. Its direction is opposite, the magnitude is the same. Now I have to stop a little bit and ask. You are in your second semester. Have you done linear algebra? No? You? Okay. Who knows what is a vector? You know what, okay, everyone knows what is a vector. But how do you know if you don't learn the linear algebra? From secondary school?
High school, yeah.
High school, okay. So that will help. Do you know, can you derivate? Integrate? Do you know Newton-Leibniz rules? There are proportional and improportional integrals, and you can calculate the value of the integral with Newton-Leibniz theorem. No? Okay, doesn't matter. Then, if you see something that you don't know, tell me. I explain. Situation much better than with Hungarians. 1 year ago, when I was in Page, we had a test in November. We had 2 midterm tests. And the foreigners and also the Hungarians wrote the same tests. And the average for the foreigners was 2 grades higher than the Hungarians. Then I got a shock. The subject, the syllabus of mathematics changed in the secondary school, and many of the Hungarians didn't learn that the foreigners learned. And that was the reason, but after a while they got the same grades, just they had a quite hard time. You don't have this problem then. Okay. Why I stopped the jump this second one? Because that's the most important. This is the equation of motion, the explanation of everything. And now I'm really just like, I don't know what is it. So you should know what is impulse, you should know what is force, velocity, and derivate. If you know the force on the body and you know the mass, then you got the acceleration. And for the acceleration, you can have the motion. This is flying in the under the water. Do you know what is differential equation? You know the others? No. Okay. Why is this motion is absolutely useless. You have the force, not that force. You have M, and you have this one. But what's this? This is the second derivative or
You use R for distance.
sorry?
Did you use R for distance? Like meters?
Yes, that's distance. Yeah. Thank you. Do you know what are the conditions of the bad lecture? Write formulas on the table and don't explain them. That was the first. Second, write and cover it, and then erase it quickly. Do not let you to write it down. One professor of me told me, so yes, this is the position, location. Why I did this? If you have, for example, and this is the mass. And this is the force. For example, at springs, now I jump. The force is proportional with the strength, the movement of the spring. So if you have this one and this one, then you have something this is a proper differential equation. You have a function, the function's derivates, and they are in one equation. And this is come from Newton's law. I jumped 5 years or 6. This is not very nice, but this is in the syllabus, and that's why I use this other camera. I will talk about Newton a little bit, and okay, which is important, this could be written as a derivative of the impulse. You can write the impulse as the multiplication of mass and velocity. And here we assume that the mass is constant. That's true here. Next year it won't. That's the special and general relativity theory. Okay.
Can I ask a question?
Yes.
It's okay if we use our own symbols for, like, for example, for spring constant, most of us learned instead of D, like a K.
You can use whatever you want. I have to check what you use, but sometimes that's perfectly different. And also, we are not Hungarians. Do you know the Greek alphabet?
Yes.
Okay, because most of the Hungarians do not know anymore the Greek alphabet, alpha, beta, omega, kappa, phi, anything. Not all of them, but many of them. Someone, when I taught math teachers, asked, what is eta and what is omega? And I was a little bit shocked. But perhaps you are different, so I don't know, I haven't known each other. Okay, other jump, work. That's one thing. You have a force, and the force has a way, a displacement to work. It's called work. Not work, it's to interact. So that's the work. That's the definition. I hope you are happy. You know this. The mass, actually there are two different mass. One is the inertial mass. If I put you in a basket, sometimes I did with my daughters, and push them, it's difficult to accelerate. That's one type of mass. The other, for you not, but with me, is some, meet some distortion in the space-time, and I have some gravitation. That's an other mass. There is a detailed explanation, but I will not explain you. Just there is something. Okay. If you have one mass, one velocity, you have displacement, you have the force, and now you are in trouble. That's why you need this Newton-like stuff. Do you know this type of integral? Everyone? It's nothing more just a special sum. Okay? It's you from the point A to B, you have a force. You can move the mass before it. You can do this stuff, and then you will get the difference in kinetic energy. The kinetic energy differences come from this work. Work done on a body changes its kinetic energy. Okay. I think we should need more practice. There are very deep stuff in mechanics and the universe. One of them is the conservation of energy. Here what is written is the mechanical energy. You have the force, and yes. You have a special potential, and let's jump it. No. I have a strange behavior. I like if you understand what I'm telling. This is can't believe it, but what I wrote here and what is there are the same.
But there are 5 potential energies.
Sorry?
5 potential energy there, right?
Yes, this is potential energy about that one, and which is the meaning of this, without any detailed explanation, is the kinetic and the potential energy, the sum of them are the same. This is written there, but no one understands, I think, without explaining the science and everything. What is here is the same. You have here kinetic energy, you have an altitude, you have a mass. When you are here, I am here, it's okay. If I'm fed up, I jump. Then, before I'm smashing with the ground, I have kinetic energy. This energy, I don't have, but it has a potential actually, and this transforms because of the work of the gravitational force to kinetic energy. So this potential energy became kinetic energy. So this is the science, and this is what you can see. It's the same actually what I explained you. There are more detailed stuff. Actually, there are forces, for example, gravitational forces, and there is a potential. And the potential's gradient is the force. What is a gradient? Do you know what is a gradient?
Yeah.
You know?
Rate of change.
It's,
Rate of change.
yes, but what? It's advanced. When I learned physics, I was a physics student, not a teacher, the scientist. I had 5 + 4 hours in linear algebra and advanced analysis. You have a field, something, with scalar, and it's scalar. It's not a field. You have something that's scalar, and you have points. Location points, a vector. You use the knob law. Knob law is a derivative operator, and you meet a derivative, and that derivative is the gradient, and that gives the force. But it's not possible to explain in this moment because you don't know in mathematics. But then I don't know why I explain you this. Doesn't matter. We will become more smarter together. This is what should be, is you have potential energy, you have kinetic energy, and the sum of them is always the same. We will use this in homeworks and practical exercises. Okay, so some more understandable stuff. Yes, the order is not good. This guy is Johannes Kepler. I'm not sure whether he was a German. I think he was a Polish guy, but at least doesn't matter. So he was an astronomer. Tycho Brahe was a Danish astronomer, royal astronomer. He had many duels, Tycho Brahe, and they say he died because there was a feast, a royal feast, and he didn't have a stand up and go to the toilet, so his urinate was somehow destroyed, but doesn't matter, I don't know. He had a very simple tool, it's not telescope, tool. It's like a sextant, and he measured the position of the Mars. And in that time, that was in just after discovering the America, they need information about positioning. It's easy to find the position on the ocean, on the North Hemisphere, because you just measure the altitude of the Polaris, that's a star. but the longitude is more difficult, and for this they could not make a clock for a while, a mechanic clock that working on the sea. So they need tables when planets rise and set and everything, but they could not determine when is it, because they could not determine the orbit of the planets. Then they thought the sun is the center of the universe. The Earth is the center of the universe, and the sun and the moon and the planets are orbiting around it. It's not true. But they didn't know what is the truth. This guy, based on the measurements of Tycho Brahe and a lot of years, decades, determined the orbit and orbital movement of what is the name of the planets. And the Kepler's law was that the orbits, so the planets and the Earth are orbit, an ellipse orbit around the sun, and in one focus of the ellipsis is the sun. The planets closer to the sun moves faster, further they move slower, and he had also an equation for this. Doesn't matter. There was another guy, a jump, not this one, this is a bit nasty guy called Newton. This Galileo Galilei, he had many experiments with gravity. The dropping stuff from the Pisa tower, it's not true. He used ramps for it, but he determined some feature of gravity. The gravity is not depend the quality of the material, and if you don't have atmosphere like this guy in the moon, then a feeder and the hammer are accelerating the same velocity. This guy, Sir Isaac Newton, he said, I could see further because I stand on the shoulder of giants. These giants were Galilei and Kepler, because empirically they determined the law of the motion and the law of orbit and everything. He explained. There is a superstar in the physics called Albert Einstein, and compared to Newton, he's quite weak. This guy lived in the time of the English Civil War and before. He died, he was born in the year when Galileo died. But he, in that time when people cannot read, cannot write, cannot calculate, and died quite quickly, he determined the mathematical analysis, derivation, integration, differential equation, solving differential equation. And he applied it for physics. So he was a real genius, the real genius, and finally he explained a lot of things. He lived in England, perhaps that was UK, I don't know, England, I call England, which is quite good because otherwise he would have been burned at a stick or something like this, because he understands that the laws of physics are general in heaven, in the sky, and also in the ground. Everywhere the universe are, everywhere. That's very important stuff. That's a parabola, and these are the orbit of the planets, and the motion, law of motion are the same. There is this stuff. This should explain how the planets are moving, but it's difficult. Let me return to this Newton guy. He was not a nice guy. He was very successful in his time, and you don't know Leibniz. You never heard this name, Leibniz. But it's not really physics, just I want you to know. No, not this one. No, where is it? Okay, something is bad. Okay, have you seen this formula? This is the Newton-Leibniz formula. You never heard about it. You heard about it, just you didn't know that that's the Newton-Leibniz formula. Great. Now you know. Actually, you understand the deduction with it when I used with kinetic energy and work previously. Okay. This formula was made by Newton and Leibniz at the same time parallelly. Newton lived in England. Leibniz lived in Switzerland. Then they have an argument. Who was first? Lot of ugly things happened, nasty. And then Leibniz asked the Royal Society in England to make justice. The president of this Royal Society was Newton. So he finally broke the spirit of Leibniz. He was perfectly... he took care about Leibniz, so that's the second meaning. And Newton was very bright. He broke the spirit of Leibniz. Later, he was the director of a factory where they made coins. And it was against the law if you made fake coins and fake money. So Newton had some campaign at the end of his life and hanged up some people. So he was not a nice guy, but very brilliant. Okay, let's return to gravitation. This is something like, I don't know, it's Facebook or like I was on holiday a little bit. You have two mass. That's M1, M2. There is a distance between them. And with this formula, you have the force between them. And there is a constant, that's big G, I learned gamma, doesn't matter, which have determined them. Which is very, very important, this R square here. It means that if you go, for example, 60 times further from the surface of the Earth, where the Moon is, the gravitational force is 3,600 lower than on the surface. There are a lot of things that we could do with this. When we will have calculation here, then we will just use the constant value at the Earth. But if you go to the geostationary orbit or you go to the distance of the Moon, then the gravitational force is much, much lower. The gravitation is very, yes?
Why do we use this G for Earth?
We will use that. The small g.
Yeah.
That small g is a vector. This is a constant. I would use gamma.
Yeah, but if it changes with distance, would it be different, like at different distance?
We can use with this small one at the Earth. We use what is comfortable for us. If you are at artillery in the military and you have to shoot something, then you calculate with constant g. If you need to calculate the orbit of the spacecraft, then of course you will use the other formula. We always use which is comfortable for us. This is actually physics. I would start with this one. The physics is I cannot tell you in English. It's a model. So you always have a model. And this model is not a reality, but close to the reality, and you have prediction. And if the prediction with the model can be checked by experiment, then the model is good. Until you find something else that breaks this model. You still can use the classical dynamics, but if you have weird things, for example, you cannot explain how the GPS working or why. For example, if you go close to the speed of light, then the classical dynamics is not valid anymore. But further, in low velocity, it's still good. Should have explained you in normal way what is experiment, what is other anything. Doesn't matter. Now we have this subject. Okay. The gravitation and also the electric potential is so-called conservative force, conservative potential. It means that is written here, if you have one position here, other position here, then the gravity will give you some work, and that work will be exactly the difference of the gravitational energy at that point and that point. There is the gravitational energy, a potential energy. Its derivative is the force. It was not defined before. That's a bad thing, actually. It actually comes from the integral immediately. You can come here this way, or this way, or this way, or this way. You will have always the same work. That's called conservational force. There are others. At the end, I will show you non-conservative forces. In gravitation field, if you have work, force, or everything, the full energy will be also the same. Okay, this is something that you are not prepared exactly. Do you know what is first, second, and third cosmic velocity? Anyone? Yes, first one? No?
Oh, the first one is to get into the Earth's orbit.
Yes?
The second is to leave the Earth's orbit.
Yes.
And the third is to leave the Sun's orbit.
Yes, yes, that's it. The first one to calculate is simple. We have the International Space Station and it's always falling down. Just it has a perpendicular velocity and it falls around the Earth. I should write down the rotational or centripetal acceleration. It's easy. This one is something different. This is the second one. You are in the gravitational field of the Earth. You have a mass, you have a velocity, and you want to leave. And if you leave, then you have enough velocity to escape from the potential. Yes, welcome in the Hungarian Spring. You know, I lived in Finland, and it was very nice when during the Easter in April we have snow. Also, the snow in May was nice. And when my first daughter was born, I went to the embassy for her passport. And it was June 20, and also the snow fell. But it was just a short episode, don't worry. It will be very, very, very hot very soon in March or April. So the spring is almost here just. Well, we have some monetary setback. Okay, we want to leave the gravitational field of the Earth. The gravitational potential is M, M is the mass of the object. M is the mass of the planet. R is the, what is the name, the radius of the planet. Velocity is the second cosmic velocity. I can remove this M, small m, and after ordering I got this formula. And this formula is the necessary velocity to leave the Earth. The first cosmic velocity is 7.9 km per second. The second is 11.2 km per second. To leave the solar system, I don't know by heart, but it's something 45 km per second, because the orbital velocity is this one without the 2. So the difference between the ratio of the second and the third cosmic speed is square root 2, 1.41. Okay. Okay, great. We have still 5 minutes. I talked about conservative force. There are non-conservative forces. Very simple, and it's around us. For example, if you drag something, then there is a force opposite this drag. It's accelerated. This is not conservative, it's a dissipative force. Also, in the atmosphere, there is some drag or also air resistance, or if you have a flow and it's some viscosity, it's an inner resistance. That's also a non-dissipative force, non-conservative force. So we are surrounded with it. Usually it dissipates the energy. It has a special direction and also depends on the path. And the last thing, power. We have the power. This says how much energy you can use or how fast you can give energy to a system. So it's energy per the, or heat giving to a system multiplied by the time. You are familiar with this, I guess. Okay. That's great, because otherwise you would not understand a single word from this. Yes. Okay. So, that's it right now. We have a break, 10 minutes. I'll shoot a coffee or something like this. And check you practice what we should do together. So now I stop